In this tutorial, we'll be discussing efficiency and energy transfer. So let's see this example that we have here. When you pull the bob of a pendulum, you give it gravitational potential energy because there will be an increase in the height of the bob of a pendulum. Then, when you let it go, the bob falls and converts the gravitational potential energy it stores to kinetic energy. So, as the gravitational potential energy decreases, the kinetic energy will increase, and vice versa. As the bob rises to the second part of its swing, the kinetic energy is converted back to the gravitational potential energy. So, as the kinetic energy decreases, the gravitational potential energy will increase. This happens because when the bob reaches its maximum height, it stops and its speed will be zero. And since the gravitational potential energy is dependent on the height, then it will be at its maximum while the kinetic energy will be zero since the speed at this position is zero. So, at this point we know that the gravitational potential energy and the kinetic energy are non-proportional. When one increases, the other decreases, and vice versa. But not all the gravitational potential energy is converted to kinetic energy and then back to potential energy. As you can see in the graph, some of the energy is converted to heat energy. And eventually, all the gravitational potential energy that the bob had at the beginning is converted to heat energy and the pendulum will stop swinging. So as you can see here what's happening in the graph, the gravitational potential energy and the kinetic energy faded and the heat energy reached its maximum, and this is what affects the efficiency of the system. The heat energy will make an appliance stop working after a specific time, so that's why it's very important to study the efficiency of a system and especially electrical appliances in order to increase their productivity.